Hello everyone and welcome back to this next lecture. So in this lecture I'm going to talk about who are the potential students that should be interested in this course. So that is, who is this course for? So in general, if you are anybody who wants to work in power electronics or is already working in power electronics and enjoys programming, then this course is potentially for you. But of course, there is a more specific groups of people that I actually am targeting with this course, and that is also whom I will cover. So, as already said, the most important group that I wish to target with this course are students, either undergraduate or graduate, who are about to start projects in power electronics, right? And I specifically am doing this because once upon a time, I too was a graduate student about to start my master's thesis, and I had very little resources on how to actually get started with advanced power electronic topologies, right? The concepts of advanced switching, what can be done with some of the advanced topologies, those are very, very difficult to understand because all I had were research papers, that is IEEE transactions. And these are not easy to understand because a research paper will mainly present the latest findings. It will not deal with basic issues. It will expect you to know the basic fundamentals. So therefore, in many of these cases, once you're trying to simulate a research paper, you need help with some of the basic power electronic fundamentals. And one of those are switching strategies for advanced power electronic converters. So the other group of people who I wish to target are those who are trying to enter industry. So you are, let's say, a final year undergraduate, or you are about to complete your master's and you're looking for a job in industry. In that case, you would like details of implementation of switching strategies for the commonly found topologies in industry, right? Because it's important. If you're about to enter industry, you need to know what's happening in industry. You need to know the kind of converters that are used in industry. You need to know the kind of switching strategies that are used in industry. So these are the things which a lot of courses do not specifically help you with. That is, if you were to take a course and if you complete the course, can you feel confident about implementing any switching strategy for a commonly found converter in industry? This is what I hope to achieve through this course. And in this course, you will learn that most of the commonly found topologies, because this course doesn't cover everything and everything. This course covers only the commonly found topologies, namely the half bridge module, the full bridge module, and the three-phase module. And these modules are heavily used in industry in a vast number of applications, whether in DC to DC converters or in DC to AC converters. And therefore, by understanding the switching strategies for these kind of converters, you are in a very strong position to look for a job in industry. The next is that, as I already said, if you are looking to simulate power electronic converters in research publications and you are actually stuck with the implementation. For example, in a research publication like an IEEE paper, you will find an interesting paper describing an interesting control strategy. But this control strategy uses a three-phase converter and it uses it with a certain switching strategy which they have just described. But there is no detail on it. For example, they will say this is a three-phase converter working as a motor drive for a three-phase induction motor, right? And they will then describe a very advanced control strategy for controlling the speed of the motor. But these strategies use space vector modulation. And they have not described space vector modulation. They assume you to know it, right? But you cannot simulate the system. You cannot simulate the induction motor, nor can you simulate the converter completely until you know space vector modulation. So therefore, you are stuck at an implementation issue. And this course I hope to help students of that type who are stuck with such implementation issues with details of simulation of converters, right? Details of simulation of switching strategies for commonly found converters so that they can then jump over these obstacles while doing their research projects. And of course, the last background is that if you have a background in electrical engineering and you are already learning Python and you want to learn how to use Python in power electronics, right? So you have a background in electrical engineering, you know a bit of power electronics, but you want to start learning on this new technology, how to use Python in simulations for power electronics, right? In such a case, this course can also be interesting to you, because not only am I doing simulations, I will also be introducing a few interesting techniques using basic Python programming for performing frequency analysis, for creating vector diagrams, and even for assessing the capacity of a converter. These kind of few concepts will be provided. So these are not actual simulations, but rather general Python code, which you can always use, right? So if you are interested in using basic Python programming in power electronics and electrical engineering, you could also find this course useful. So now that I've talked about who is the target student, I will talk about who should potentially not take this course, right? Because this course is not for everyone. So who should think twice before taking this course? If you are looking for a course to help you pass your university college exams, right? If you have exams coming up in a month and you're looking for a course just to help you through the theory, please do not take this course. This course is not going to help you with your university exams. This course does not cover basic power electronics theory. I have no idea what comes nowadays in university exams, right? I am not a professor, not a college professor, and it's been ages, it's been more than a decade since I have graduated. So I have no idea what is coming nowadays in today's exams. So if you're trying to take a course to help you pass your college exams, this course is not it. Please stop now. If possible, even request a refund. You're wasting your time and money, right? If you are looking for a general overview of power electronics, like you want to know what's the latest applications, you want to know how photovoltaic panels are connected to the grid. You want to know about what's happening with offshore wind turbines. You want to know what's happening with electric vehicles, right? You want to know about the latest happenings in power electronics. In such a case, this course is not for you. As I already said, this course doesn't deal with applications. I will not be talking much about what's happening in the power electronics industry. Instead, this is a very deep course where I talk about only one potential problem, and that is how to generate switching strategies to extract the maximum from your converter, right? And it is heavily simulation based, right? So you might end up watching hours and hours of me simulating a converter when all you want to know is how is the converter used in an electric vehicle. So you're wasting your time, right? So this course is not really for you. Please take this course. If you're willing to spend hours simulating, you want to simulate, you need to simulate, and you're willing to learn how to simulate. The next is, if you're looking for a course to help you program a specific microcontroller. Let's say you have a Texas Instruments microcontroller that you are using in your course and you want to know how to, or you're using in your project, and you want to know how to program it to get a job done. You want to complete your project. That's it. In that case, this course is not for you, because I do not deal with specific microcontrollers. This course has no real embedded systems background. I will talk about some hardware challenges once in a while. When I describe a switching strategy, I might say, okay, this might be an issue. This might be a challenge in hardware. And these kind of things I will talk about, but it does not have any details of any microcontroller or FPGA or any embedded systems. So if you have a specific problem with a particular microcontroller or an FPGA, again, this course is not for you. It won't help you, right? This course is mainly to understand power electronic converter switching. That's it, right? The last is, if you're an electronics hobbyist and you're just looking to pick up some basic knowledge of power electronics, right? You just want to know, like, you have basic knowledge of electronics. You've been playing around with microcontrollers. You've been building small little amplifier circuits, and you want to check out how, let's say, for example, you want to build a servo motor. Let's say you want to build a controller for a servo motor or something, or a small robot, and you want to take a course just to learn about power electronics. Then again, this course is probably not for you. Alright, this course is really meant for those who are trying to get into power electronics, do a project, get into the industry, learn what's happening in the industry, get a job, and actually become functional in their jobs. And this course has the simulation for that. Right? It has details of simulation, details of theory, details of description of converters, but this will not help somebody who's just trying to play around with power electronics, right? So if you are any of these categories, I would say please think twice before taking this course, right? This video lecture can be watched free of cost, so please watch this before you register for this course. And if you are in any of these categories, please think twice before you take this course, because this course may not be helpful to you, and I would not like you to feel disappointed and leave a bad rating, right? That's not something that I want. So I hope this was clear in terms of who can benefit from this course and who might not benefit for this course. If you have any doubts, if you still have any doubts, if you're trying to do something, if you have a particular objective and you still think, can I benefit from this course? Please post on the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture where I will talk about some of the requirements this course has, right? So thank you so much for listening and goodbye for now.